Today's a very special day for the DeFi ecosystem. One of the core players, Safe, the multisig that secures hundreds of billions of dollars of crypto assets, has announced that their token is going to be transferable. In today's video, we discuss what this means for Safe users and the importance of smart accounts going forward in crypto. There's been a lot of talk about EIP-3074, as well as Safe's new Keystore Rollups. In today's video with co-founder Richard, Rob and I dive deep into what this means from a technical architecture standpoint, and also how the Safe token will play a part in the future. Hope you enjoy. Thanks. Welcome back to the Rollup. Today we are here with Richard, one of the co-founders of Safe. Today the Safe token has been announced as being transferable. So a lot of work has been put in by the team to create basically the bedrock of all of DeFi in terms of asset management and self-custody. Rob, we have the pleasure of sitting down with Richard. I know that we did an episode with Lucas, the other co-founder, maybe 3-4 years ago. So glad to be back.
Yeah, it's a testament to Safe's long-standing history and fundamental presence in DeFi, Ethereum, and blockchain space in general. So yeah, like Andy said, episode with Lucas was quite a few years ago. A lot has happened since then. And there's still a lot more that is going to come out over the coming weeks and months here. And so we anticipate that the nature of custody will start to change. And this new paradigm of account abstraction will start to take shape. And so I think that's probably a good place to start, is just defining account abstraction, maybe defining like the problem statement here, and then we can start to dive into some of the proposed EIPs and therefore proposed solutions.
Sure. So first of all, happy to be here. What is account abstraction? I think there are many ways to it, but looking at a technical level, right? Like if we look at especially Ethereum and other blockchains, how accounts are defined is really this very strict definition of, okay, you have a cryptographic key, it's a key pair, you have a public private key, and it's even defined down on the curve, like what curve are you using? And while you have some freedom on, okay, how do you utilize this curve with MPCs and others, it's in this case, it's quite strictly defined. And if we want to be more flexible, we have to do major changes. And here it's where account abstraction comes into play, right? Like, so basically we want to abstract away this definition. In Ethereum currently what we have is that we say we have an ECDSA curve, which is based on SegP K1, and you have an increasingly monotonous nonce, which depending on your actions, like executing a transaction, deploying a contract, it increases. And both of these you can basically open up where you say, okay, actually, we do not care about your cryptographic curve. We just say you have a smart contract and you can call into the smart contract, and this smart contract can, however they want, verify a signature. And we even go one step further. We can say, however, what replay mechanism you want to enforce, you enforce it yourself, right? Like where the protocol normally enforces is a monotonous nonce. And these are the very core basics that you will always have when it comes to verification of your account. But especially on the blockchains, obviously, you also have the fee payment part, which is then another level to it where you say, hey, normally you have to pay in your native coin. Nearly all blockchains. There are some exceptions, though. But even there, with account abstraction, you could even go take this step and say, yeah, it's actually not necessary to pay in your native coin. You just have to pay somehow so that some validator or miners accept your transaction, your payment, right? And if we take all of this together, then this is really what we see is on a blockchain level, account abstraction. And if you then want to even go further and go outside of account of the blockchain level, it's where you then also enter into the dApp and off-chain level, where we say, obviously also dApps nowadays assume certain things about accounts. They use EC-recover to recover your identity and check that you can log in certain platform and that you have control over a key. And also there, we really have to make sure that this account abstraction comes into play, where they don't assume that this is just a fixed key with a fixed curve, but that we can say even dApps should call into a smart account to verify, okay, how is this really a signature that belongs to this account? And this is where you have the different levels of account abstraction coming in, and most likely this will extend, but yeah, and currently most of the teams, or a lot of discussion also, especially in the recent day, is actually about this blockchain level account abstraction. How can we progress here? Because this is really what will empower smart accounts and really push us forward to cover all the use cases that we at Safe believe are necessary to bring in the next wave of users.
Yeah. And so we have the core fundamental principle is about making this on-chain experience from kind of these externally owned accounts, these EOA wallets, to kind of this more smart contract based account wallets that uses a different mechanism of signatures and of potential for automation, gas tokens, and just broadly pushes that through.
Exactly, right? Like, so I think the prime example when it comes to this curve is always this, when we talked about in the past, at some point, quantum computing will be at a stage that ECDSA is not the right way to go anymore. And currently that would mean we have to change the fundamentals of the Ethereum blockchain, and nobody knows how it would look like. And they're having account abstraction where you would say, okay, it's up to the smart accounts, and smart accounts actually can support multiple signing mechanisms, what we already see, then this is a smoother transition. Right? Like we see this already, that smart accounts that are out there support mechanisms that use the SEC-PR1 curve, which is the one that all the common smartphones support. We see mechanisms out there that use BLS signatures and even ZK knowledge proof, right? Like, and if we look at BLS and zero knowledge proof, that's where you then go into the domain of being actually quantum resistant, and we therefore would be ready for the future. But at the core, Ethereum has not moved away from that. Everything is based on ECDSA signatures, so we still have this dependency.
Okay, give us like a quick like cryptography 101 when it comes to these curves, because there's like these different curves. You mentioned that there's an account. It's made up of a public and a private key. But then to make interactions with those accounts, we need to do signatures. And these signatures exist on curves. So how does the cryptography work here? Why are we choosing between curves? What's the difference? Why does it matter that we're on one? What makes one curve quantum resistant while another one is not?
Okay. I cannot go too much into details. It's not the biggest domain, but very simplified speaking, right? Like nearly all cryptographic, like everything on a computer, but especially in cryptography, it's just you have different mathematical operations where you say in one direction, like you can do operations that partially you can revert to verify that they're correct, right? Like, and it's actually basic mathematical operation on very, very large numbers, and normally on very large prime numbers. And to really do these back and forth calculation to verify it, you put them onto a curve. And it's very important what curve you use and what parts you keep secret. And this is where then the first discussion comes in, right? Like, how big can these numbers be? This is, if you look at certain cryptographics, and it's like they are 1024 bits wide or 2048 bits, right? Like the wider normally the stronger your encryption, because the bigger the numbers can be. And then the curve is really where you say, this is when ECDSA, you have a K1 and an R1 in the name of these curves. Somebody just defined random numbers that make up these curves. The R1 curve is a random number. Nobody knows where it's coming from, basically. It's recommended by NIST, which is one of these bigger institutions existing in the USA, and where then people, especially in the crypto world, say, who knows where they got this number from? Might be compromised, might be not. Fun discussions when you go in especially in the Ethereum research forums where this is being questioned and there's a big discussion around this, where this then shows basically Bitcoin shows the K1 curve where they said, look, this is how we derived it, and therefore we believe that it's not compromised. And then obviously these are quite, actually not the young, like all of this cryptography is not quite new, not the newest, but then you have BLS, which is a newer curve, which new crypto curves have always normally more advanced mechanisms. For example, for BLS, it's easier that you can aggregate certain signatures, which is if you transmit them over the internet, obviously aggregation is super awesome because you can better compact them. There are a couple other features also when it comes to how you can basically use distributed key generation with BLS and so on. I think there's a lot of research there, but obviously, the newer it is, the less you know about the curve, right? Like if you have something, and we see this also with Safe, if you have something that is running for years without any exploit, it builds trust, right? Like, and every new cryptographic curve, you always start questioning this again. And then when we come to quantum resistance, it really depends how do you chain certain mathematical operations that make something quantum resistant or not. And this is where newer cryptographic curves do different operations. Again, here disclaimer, I'm not a cryptographic expert. It's basically the one-on-one simplified, and this is already the simplified version of cryptography. But yeah, and then I think the fun part actually with smart accounts come into if you have something like zero knowledge proofs, this gets a whole nother level because you basically you do cryptography in a secret environment. You do it in a way that you can prove that you did it, but you actually don't share anything of what you did, right? Like, and there are fun articles here about where, like, what you can do, but this goes a little bit beyond the scope here. But yeah, so the importance is always big numbers, right? Like you want to have big numbers, big prime numbers. Prime numbers are hard to find. So this is where a lot of the magic is coming from.
Okay, and the fundamental change in smart accounts and account abstraction, are we changing the curve, or are we just operating amongst this curve in a different way that allows us to generate these signatures more easily or among different components?
So fundamentally, you can still use the same curves. What you want to do is you want to completely be flexible what curve you use, right? Like right now you say you use a specific curve, like with a specific parameter. And what you want to do is just say you can use any authentication mechanisms that has a specific interface. So if we take ERC-4337, for example, they have this validate user op function. And the contract then can decide, do they use a curve? Do they just blind approve every operation? And well, it's also an authentication mechanism if you want to take it like this. Do you use zero knowledge proofs, or do you have some fancy other way that nobody knows about yet, right? Like, but it's up to the smart contract, and it's not dictated by the protocol. And this flexibility obviously then allows you to even combine multiple of these mechanisms and adapt new mechanisms once they come up.
Yeah, it's kind of the beauty of crypto is the optionality and it's the flexibility, but oftentimes that is the cause of the most friendly debate and research, which kind of brings me to a tweet that you put out the other day with regards to this idea of the types of account abstraction, and this kind of funny meme here, which was basically that there's devs are excited about 4337, but we've got this little pink guy here with 3074. And I know this is comical to you, but probably quite confusing to many. So let's dive into 4337. Let's dive into 3074. And it was on one of our recent shows that Ajit from Hadron spoke about this kind of dilemma as well. So clearly it's making its ways around the research community. Why don't we start with 4337? This was kind of the original ERC standard proposed, and now we're moving towards different solutions. So at a fundamental level, what is 4337? And maybe we can talk about your preferences as well.
Yes, so on a fundamental level, 4337 proposes some of these interfaces and standards that I mentioned before. Right? Like, so they're actually quite deliberate to say, here you have an interface which is defined. When a smart contract implements it, you can call into it and then you verify a signature. And additionally to this, they separate it quite clearly from the execution, which is actually, we are used to it from Ethereum, right? Like when you use a normal smart account, your signature is validated by the protocol, then the fees are deducted, and only then you execute the transaction data or the transfer, right? Like, and this is basically also what the protocol does. It says, okay, we have two parts here, and one is the validation and one is the execution. And then additionally to this, ERC-4337 also defines, okay, how do we allow smart contracts to submit transaction? And they create basically this alternative mempool, which has its own restrictions and where you also have your own gas fee market, basically. And this is important because, and this is also the reason why it's an ERC and not an EIP. UOP especially makes this distinction very explicitly, is that 4337 is a way that we can collect information about, okay, how does it actually work? What limitations do we have to put in place for this to become an EIP so that we can put it into the protocol? Because all this flexibility that brings obviously opens up certain attack vectors. Ethereum is quite strict around like nonces need to be monotonously increasing, because you can do certain checks up front that balances are not changing, because, your Ether balance can only change if your nonce increases. You can otherwise not lose Ether on it. And this obviously is a denial of service protection, so that we cannot just suddenly that the blockchain comes to a halt. With smart accounts, all of this needs to be reevaluated, and we need to collect this data. It's a big research topic. There's a lot of things where we make assumptions, but how it really works out, we don't know. And this is where 4337 as an ERC is super helpful. It allows us to look into this and to understand it. But to really get measurable data, we need that projects adapted, that we have enough traffic. Because it's like running a server and you say, my setup's awesome, and you have like 50 requests per second. And if you go to any bigger team saying 50 requests, you don't know if your server is really scalable or anything, because it's no traffic, right? So how do we get the traffic up? And this is where we are pushing towards to adoption, right? And this is also where, especially in the last year, from the Safe team, we said, because you mentioned my preference, right? Why potentially for Safe it's not the easiest to adopt 4337. We have an existing contract. It's a completely different execution flow. It's hard for us to adopt, and the immediate benefits are not not the super biggest, because, it primarily solves for us the problem, how do we submit transaction? But for the wider account abstraction ecosystem, right? This is necessary, and where we also say it doesn't help us if we say, let's try to do our own thing, and then as a smart account ecosystem, we do not move forward. And this is really where you say, okay, we need to engage also there. We need to collect data. We want to see how this pushes forward, because our end goal is still that we have native account abstraction. So this is really where 4337 is really it's not the end goal by no means, it's the starting line. This is really where we start thinking about native account abstraction. It allows us to collect data and figure out how can we really solve it, how can we push it native.
And you mentioned a couple of use cases that account abstraction enables. Could you just kind of go through what those use cases are that are not possible today, but with account abstraction are now possible?
Yes. I'm gonna recount this a little bit without 3074 in regards, because this changes a little bit what is possible only with smart accounts and what is possible with others. But in general, with smart accounts, you the one thing is that you can define better the control over your account. I mean, I mentioned before you have different curves, but actually, since it doesn't have to be only one key that controls, right? You can have multisig, you can have permissions, you can have nested hierarchies. This is what we're very used to from Web 2 in organizations. This is really where you say, this is where smart accounts can put this on chain in a trustless way, right? We know that it's also possible with NPC to some extent, but really smart accounts bring this completely trustless on chain. Another part, which is what you can also add there, is actually that you have checks. And this is where we really at Safe say this is a pathway to engage also in the wider ecosystem. It's what we call hybrid custody. Basically, because we all want full self-custody, but self-custody is scary for a lot of people. So giving them a helping hand, where you say you have security checks, where certain transactions need approval from more from an external insurance or something, or at least in a normal case, else you need to have time delays and so on. This is really checks that you can implement and customize per user on a transaction basis. So there's a lot of flexibility in this regard. Besides this, you can also do a lot of convenience features that overlap with security. For one is something like session keys, right? Also this something everybody uses in Web 2. We use OAuth in basically every application, where you can give permissions for a key that certain applications can do certain actions without having to ask username, password for your whole account. This is something where with smart accounts, we can really say, okay, certain actions, we have our special key, and this can perform certain transaction with certain protocols without having to get the confirmation every time. Another example for this is daily limits, where you say, or recurring transfers, right? Daily limits, you say up to a certain limit, you only need one approval, not multiple one in a multisig. Recurring transfer is also what we used to, right? Let's assume Netflix at some point would go fully on chain and you can do crypto payments. We don't want to manually trigger this payment every time. We would want that it automatically just gets executed once every month, right? So these are some some of these convenience features. And then another big section is recovery. And there we really say users lose their passwords, they lose keys, right? Like, and this is one of the crypto things where we are all like, we better not lose these keys because else we're gonna go to some garbage dump and try to find our old hard drive or whatever, right? Like, this is a general picture that everybody, when we talk about crypto, that's what they all think about what we are doing the whole day, right? Like, and this is where really also their smart accounts can come in, where you can say, actually, you can do key rotation. You can have mechanisms where you can say you trust a group of other people or another entity without giving them power over your account. You can have time delays. There are mechanisms that are called dead man switch, where you say if you can somehow prove that your account did not do any interaction for the last month, then you're allowed to switch out the keys. Like, this provides just a lot of flexibility where we say, yes, self custody is awesome, but it's also scary. And if we really want to get more people on board, we need to be able to have the flexibility to really provide the tools that it's less scary.
Yeah, I think the automation and the social recovery were the two things that got me most excited. But I think that the gas tokens what gets a lot of people excited about not having to or being able to use any token for gas. Oftentimes you just kind of get stuck in a chain where you don't have the token. This happens. And so we see that there's a lot of these evolutionary benefits of smart accounts, which it makes me feel like crypto is still so early. Sometimes you don't feel like it's early, but shit, it still feels early. And yet there's still some better evolutions to come from your perspective from a different model, because ERC-4337 is a standard, right? And standards have to be adopted to be a standard. If I adopted and you adopted, Richard, then I mean, we might as well just call it like a friendship, right? Or a handshake. So 3074 comes in, and you're excited about this. What are some of the additional benefits which can be seen from 3074, or kind of what are some of the pitfalls of 4337 which you find 3074 to be more appealing?
It's interesting. I think,
or maybe I'm putting words in your mouth.
Yeah, it's not what I was suggesting with my tweet. To be fair, first of all, what is 3074? Let's maybe start with this one. Like, 3074 is actually primarily giving away that you as an EOA can give control or authority that to execute transactions through your account to a smart contract. That's a very interesting feature because in general, if we talk about it in the smart account ecosystem, this is to empower EOAs. It's not really empowering smart accounts, because this is basically allows you to do a lot of the stuff like session keys, what I mentioned before, automatic transfers with EOAs. This is where we from smart accounts say it doesn't benefit us immediately, the smart accounts. But it's not that simple, right? Like, and also the meme that I was doing there, it was not about this, is 3074 good or bad on a technical level, because it's actually a necessary step that we have to do. I would have done it at a different time, but it's a necessary step. And I think especially with Lucas together, we had a blog post actually released today where we were talking about this, where the end goal is native account abstraction, right? Like, we want that on a protocol level. It's not an ERC, but it's really on a protocol level. We have everything as a smart account. You have the full flexibility to do everything. And there are many ways going there. And the way, at least also in my head, that we were going was, okay, we start with 4337, we collect data with 4337, then we look, how can we push this native with EIP-3074, for example? This is one native account abstraction on L2s. If we have more data, then we push it on mainnet native, and then we get to the point we need to provide an upgrade path for all the existing EOAs, because they somehow need to become smart accounts too, right? Another direction could have been that we say, let's just keep empowering EOAs until they become smart accounts. Right? Like, it's also a viable direction. It's, and actually, for us, 3074 goes a little bit more into this direction. And what then the challenges that we see is that, okay, if we go into this other direction, we have to make sure that we just don't pull focus away from the one direction, that this then slows down and we start working on something cool and new because, it's immediate new thing that is there and that we can go for. 3074 definitely provides a lot of opportunities also, since it is more empowering EOAs. Big teams that are EOA based, like MetaMask, for example, will engage also in a lot more new user flows that have been until now more exclusive to smart accounts, which will create adoption also in dApps. What I mentioned before, right? Like, because with smart accounts, it's also replay protection can be different. You can do batch transaction. All of this until now was always for dApps a hassle, because it would have to support the normal flow for EOAs that doesn't support this, and the one for smart accounts. And normally they say most of the users are still EOAs, so let's stick with this, and you don't get the full developer experience. And this is really a benefit where you say, okay, we can go into this direction, but especially at Safe, believe we would want that we also commit to the next step with, that comes after 3074, which is like, let's allow a way to upgrade an EOA actually fully to a smart contract, to smart account. And this would be then EIP-3073, which also has its challenges, technical challenges there, right? And this is really where this challenge where you say, okay, now thinking about this, it takes a little bit away the focus that actually the whole AA ecosystem had on 4337 going down the road. And this maybe not the best meme that I took there, but this was basically my focus. It was not about, is ERC-3074 better than 437, or do they not, like, should we do either or? It's more like suddenly we had a lot of focus on 437, a lot of teams pushing forward this, and now part of them at least will say, oh, let's rather look at this and let's focus on this one.
Perhaps a meme choice could have been the guy with the girlfriend looking back at the 3074. I think that one would have been a good one. So it's not so much about the preference, but it's more about like the timetable in which this process could take, in that starting with EOAs where all the users are, you're kind of going where they are, and also where all the infrastructure providers are, and then trying to do that transition is going to be an easier process than trying to basically adopt a new standard and then go into an EIP. And thus the paths could be a little bit divergent if 3074 plays out how you see it leading into 5003, rather than going directly to 4337.
Yes, and I think the biggest challenge, or what we see as it's gonna sound better, but like the worst case, what is that we actually stick only to 3074, and then, as said, 3074 in itself does not provide many benefits to smart accounts. It actually empowers EOAs. And what happens if you empower EOAs is that people stick with EOAs, and it basically then, in the end goal of getting native account abstraction, then rather really creates some inertia that we then have to accelerate again, right? Like, and this is especially important to consider when we look at the hard fork roadmap of Ethereum, which is actually, we have Pectra, which is the EIP 3074 is now planned to be included, which is happening in the next 6 months, more or less. And then we have basically 1 to 1.5 years, which is allocated to worker trees. So that means after this next hard fork, there is for 1.5 years nothing going into further new EIPs that would go beyond 3074. And this is really where the discussion comes, okay, can we take the next step right now too, so that we do not get stuck for 1.5 years at something where we say, okay, now it actually makes it harder for native account abstraction to really move forward and to get adopted.
Yeah, and you guys are pushing pretty forward on just wanting to get the transition to smart accounts as aggressively as possible. I mean, you guys are. I mean, this idea that you've now pushed out of Keystore rollups is like this idea where it's, I can control multiple accounts, and execute simultaneous actions amongst a ton of other possibilities, kind of from one central hub. That is very much so smart account oriented. So it seems like for you guys at Safe, whatever is pushing forward smart accounts the fastest is kind of something that you guys are going to be most interested in.
Yes, I mean, kind of obvious, since our vision is that every crypto transaction is executed through a smart account. Even better, so it would be safe, right? Like, so we believe really that to get the wide adoption, we require smart accounts. We require this flexibility that is provided by smart accounts, and this is why we are really pushing for this. Especially when that being said, right, like smart accounts are not solved. It's not that I could say, oh, they just use them, they solve all the problems, there are no challenges at all. If this would be the case, everybody would be using smart accounts. There's actually a lot of challenges with smart accounts. And one of the challenges that we have seen spinning up starting mid of last year, and especially now this year, increasingly is that we have more and more networks, more and more chains spinning up. We have this cross-chain experience. And then if you go into this way, actually with smart accounts, there are two challenges here, or two key differences to an EOA. Since EOAs are, as I said, very well defined. What is the curve? What is your public key? It's also very well defined. How is your address defined? So actually your private key, your EOA, has the same address on all chains. This is not necessarily the case with smart accounts. Why it is possible to some extent, often it depends then also how is the smart account deployed, what bytecode does it have, and then while there are mechanisms like create2, which allow you to get on a lot of chains the same address, actually on chains like zk-sync, which have by default different bytecode, and because they run a different VM under the hood, they're not 100% EVM, there you always get a different address. So this is the first problem. And the other thing is, obviously, the EOAs, they are defined, the crypto curve is defined, everything is the same. So they don't have state. While smart accounts, they have state. So let's say, simple example on mainnet, us three share a smart account. And then we have the same account. We actually manage on the same address, same account on Optimism to deploy the same. But now we change on mainnet. You guys kick me out. That doesn't happen automatically on Optimism. I'm still part of this on Optimism. So now we have to go to Optimism and kick me out there too. And now let's imagine like the safe smart contracts are deployed on over 100 chains. Let's assume we are super active on all of these chains. We have to do this on all of the chains. This is not really
problematic.
Right?
It sounds extremely
and this
problematic.
is where the Keystore rollups
then come
in.
Right? So you guys have proposed, okay, we can't do this on the L1 though, because it's a little bit expensive. Not all these users are going to be able to have a safe on the L1 to kind of control all of these different chains and all these different accounts. So you guys propose what Vitalik has kind of said as like this minimally viable rollup or something to that extent. Maybe talk us through this design.
So in general, I think to start out with, without thinking about if it's a minimal rollup, what you want to think about is like you have one chain where you update it, which is Lucas nicely put it in the word. It's like basically your password manager. It's like you have this one password manager and you have your one place where you update your owners for your smart account. And then all the other chains just reference this one. And this is simplest thinking about it. Let's assume it is on mainnet, you're safe. And since most of the rollups actually can already have a connection to L1 and can read state there, you just read the state from this account and use this for the verification when you do transaction. That means as soon as you change your owners on L1, it is immediately, or like as soon as it's propagated to the L2 chains, but then the owners are also changed on all the other chains without you having to go everywhere. So why this is nice, and actually since most of the chains can read L1 states, this is actually decently good to do. Also cost-wise, the challenge is that it's just expensive to deploy on L1, right? Like, so if you want or to execute an owner change on L1, so this is where then Vitalik says to really bring this to the masses, we have to gas optimize this. And the gas optimization here in this way would be, let's do a dedicated rollup. If you have a dedicated rollup, we can optimize on really what operations you can do. If there's really a limited set of operations that you can do and data that you can store, it becomes more gas efficient. Ethereum is also quite expensive because it's a Turing complete VM, right? Like you can do everything, which is for managing identity is not really necessary to do everything. Additionally, you can structure proofs in a way that they are easier to verify, right? Like, Ethereum mainnet, if you want to prove the state there, it's a Patricia Merkle tree, which is actually not the easiest to perform a proof. It's currently, I think, just to perform a storage proof, so to check that somebody's an owner, it's 300,000 gas. Just as a context, right, like a normal ERC-20 transfer with a smart account is 100,000 gas or something like this. So that's like you are tripling or like quadrupling nearly the gas cost, right? Like, so this is really where then these optimizations come in. But this is on a similar level as native account abstraction. It's super early, right? Like we first have to analyze how far can we optimize this rollup? How can we optimize also the communication between L1 and L2? Because even this right now is not, it's non-trivial, and there are many teams working on this. And this is actually what is really nice to see currently in the ecosystem, that even so there are the different teams, besides Safe, we have Biconomy, Zero Dev, Alchemy, all working on accounts. At the same time, these teams come together and work together. Okay, how can we solve these problems? Because these are problems that are universal to all smart accounts. And this is really a very nice momentum where we see, okay, this ecosystem, the AI ecosystem, can actually push forward.
Okay, so let's finalize the mental image of the architecture that you just explained here. So basically, we've got this Keystore rollup that is like it is a rollup that does not have a ton of apps on it or a whole lot of functionality outside of just being like this kind of password manager, if you will. This Keystore rollup is like this authentication machine. It settles to Ethereum L1 effectively. Ethereum L1 is able to send out messages to all these different L2s or rollups via like a state on like a block header or like a transaction hash and the block header, it telling those accounts to basically make any updates that you kind of request from your central password manager. And then those accounts send a state proof or a proof or storage proof down to the Keystore rollup saying like, here's the updated state. And then the Keystore rollup settles that back to Ethereum. And that's kind of like the general loop. Did I mess that up?
I think in the second half, it was a little bit, I would formulate it differently. So the first one is right? Like it's a very simplified rollup that rolls up to L1. And then actually Ethereum doesn't send out messages. It's more like that if from any L2 you want to access the Keystore, you basically read the state of your Keystore on L1 from your L2. So it's not that actually the messages are sent out. You just have mechanisms that any L2 can read the state on L1. And this way you can basically, and this reading of the Keystore is normally done via a proof, whatever. Like in this case, what Vitalik proposed, it would be a zero knowledge proof. And this one you can then takes a zero knowledge proof, and you can prove on any L2 the state of your Keystore. And here, obviously, you can do certain optimizations, how it's propagated down. And I think one of the challenges is also that the communication, how do you access on any L2 the L1 state, that this is not standardized. Most L2s have this possibility because this is kind of required. If you deposit funds into an L2, this is exactly what happens. The L2 needs to know, hey, there's suddenly my balance on L1 increased on this anchor contract. So they read state on L1, and you can utilize this method to do the same then for the Keystore.
Gotcha.
Okay, so switching gears a bit, another fundamental part of this network is the safe token, which is now transferable. And so you guys aren't going to use this safe token for any kind of economic security, like maybe a Cosmos chain that launches a token along with their network. Well, correct me if I'm wrong here, but it will be used primarily for governance and social consensus and social security around this safe, minimally viable Keystore rollup. I guess generally, what is the role that the safe token will play in this Keystore rollup?
Actually, the safe token, what role it plays in the Keystore rollup, it's quite early to say there because the Keystore rollup is quite early, right? Like where we really went with the safe token is, the safe token in itself exists for 2 years. It has been non-transferable, and the big change is just that it gets transferable, right? Like, and what we see actually the safe token representing is really the safe ecosystem. And there's a big safe ecosystem consisting of many teams. And actually account abstraction is not just the smart account part that we talked about, which is a lot like the Keystore rollup, and this is really the blockchain layer, and also how you do then certain interactions with modules. It's a lot of tooling that is necessary. Like we see it with 4337, you have bundlers. We see it with EOAs, even block explorers are necessary. And we believe that to grow this ecosystem and in a sustainable way, this is where you need some governance around, like you need some consensus. And this is really where we see the safe token can come in. And this is where really with it becoming transferable, this is where it becomes really feasible or like possible to really do this, because to really enact this, where you say this, like the safe token representing the ecosystem, which is then also new people can join the ecosystem, and the ecosystem can provide security on how certain services are running, on how certain modules, which is like this extension mode that we use for smart accounts, right? Like how are they secure or not, to give guarantees. This is where the token needs to be transferable. And this is really now that we flip the switch, it's actually now we can really start saying, okay, let's implement all of these things. And we have been working for the last year on many fronts, right? Like, and actually it was not the Keystore rollup, where a lot of this has been talked about. It was more like this security of the modular smart accounts, which I think half a year now ago that we proposed, or like that we published this safe protocol paper. And this safe protocol was like this high level overview. I'd say, okay, how do we see modular smart accounts? Because it's similar with 3074. If you give control towards another smart account, that's a big security risk. Like, because you have to trust this other smart account. And in 3074, there basically it defines that your wallet, for example, MetaMask, trust them. They will tell you what are good smart accounts that you should trust. But we inherently believe that it cannot be a centralized party that should tell you what is a good or bad smart account that you should trust. And this is also where an ecosystem comes in, where you say, look, we need to govern this. We need to provide security. We need to provide guarantees. And this is really where the safe tokens then will play a role to provide these securities. And the Keystore rollup, actually, we are so early that I could not immediately say where it plugs in there, but also there, the challenge with the Keystore rollup, as with many, will be economic incentivization. It's not for free, but in the best case, we would love that it is for free to the users. And also there, the token can play a role where you say, certain parties earn from this, and you want to redistribute it so that you can, certain parts of them, of your ecosystem can run for free. And this is something that is not specific to Safe and like the Keystore rollups. This are discussions that many teams are having for different parts, also in regards to 4337 and transaction sponsoring, right? It's one of the prime examples for 4337.
I remember the token coming out, like you said, year and a half ago, 2 years ago, maybe in the bear market, and like it was there, and I think the token amount per safe was like 2,500 tokens or something. Maybe I'm mistaken. I don't know. Could you talk us through a bit about the distribution, how Gnosis Safe owners, kind of got tokens, and kind of what that process has been?
Yes. It was nearly exactly 2 years ago. Next week, it will be exactly 2 years ago when the token was launched. And there were, let's say, I think five bigger pools maybe. And so a big part actually went to the DAO. It's like 60% of the tokens. We had a part for the team and for investors that is allocated. Then we had a big part also for Gnosis, since we're spinning out from them. So Gnosis DAO also holds a big part of the tokens. And then we had also a big part for users and ecosystem. And I think this is where I want to focus on, because this is the one where we really say, let's get them involved. When it comes to the users, we actually there's still quite a lot of tokens allocated to users that are still available for future airdrops, because the first part was primarily focused on Ethereum mainnet, right? Like we wanted to drop to Ethereum mainnet because this is where most of the traffic when Safe really started was happening. And there we said, okay, how long does the Safe exist? How many funds are you storing, and how many transactions are you doing? These are like there were some analytics done, and this is where really there was not one fixed value per safe, but this really depended on how much safe you get, because for us, we believe in that it's just having a safe is not enough, right? Like you should store funds in them, and in the best case, you should use the funds. Just holding funds is not enough, and this is where we had like this very long list. It's actually public in our repositories for the airdrop, where you can look it up on all these airdrops that were happening. And then the second part was an ecosystem airdrop, where we really said, okay, let's talk to, like actually everybody could apply and say, whoever contributed to the success of Safe. You could say, I did some educational videos, I did some tutorials, I built a project on top of you, or I actually built a full running production ready product on top of you, right? Like all of this was giving out a grant, and this was actually quite a lot of safe tokens. I think the highest one was 6 digits somewhere, safe token wise, right? Like you can look this up. It's also public information. I think the biggest contributions are like 1 million safe tokens plus something like this. So this is really also where we said, okay, we really want to continue building with these people. So we give them safe tokens. And so as soon as we really get into governance and as soon as there's really tokenomics, that these people can participate in our ecosystem. And now with it being transferable, this is really the point where we can start doing a lot of more dynamics because as mentioned, for example, the user airdrop was mainnet only, partially also, not exclusively, but partially also because bridging the token over or launching another token, which is also a safe token on other networks, is a huge overhead, which provides quite some distraction. But now that the token becomes transferable, it actually can engage with the ecosystem and say, let's bridge over a certain pool of our token to a specific network and do an airdrop on this network for the people on this network. So all of these possibilities really engage us to allow us to engage with our ecosystem and really get more people involved. And this will create the power, in our opinion.
Gotcha. And are the tokens claimable for a set amount of time, or is it in perpetuity? Like for those who are watching now, obviously the token's just gone live in terms of transferability today. How long do people have to check? Is it too late? People are going to be wondering how they can check their allocations and kind of see what they have.
So the airdrop actually happened 2 years ago, right? So this one is actually not available anymore. Will not be, chances are that there were actually 2 airdrops so far. And, I would have to check the second one, but both of them actually, okay, I have to explain our airdrops. So our airdrops, as you get them allocated, you then have to say, half of the tokens you can immediately claim and the second half would vest over a couple more years. But to be really eligible to claim the vested tokens, you have to say, yes, I would. It's an active opt-in. It's not forever there because we say tokens that we allocate to an airdrop and that just sit there forever to wait to be claimed. That is not feasible. We rather had after a certain time, the tokens that have not been actively claimed, we can channel back to the ecosystem and do another airdrop for active people, right? And so actually the 2 airdrops that we did, both are over this period. And currently you cannot claim more air tokens. That being said, also very, in our governance process right now, we had this part where we voted on transferability, and now since it was today, so it's the day of the recording, where the vote was finalized, and now we have a 8 days period where it cools down before it really goes into effect. So this is a little bit related to our governance process because we actually do off-chain voting with Snapshot. And then we have to use an Oracle, which uses an escalation game to get the result on chain. Because again, this is a fully decentralized process. It does not rely on a centralized party being the trust holder, but it's really where we say we use Reality.io, Reality.eth, where you can then play the escalation game and have on chain and trigger the execution without any involvement from either the founders or the Safe Ecosystem Foundation.
Yeah, that's really the way to get the most decentralization out of the governance process. I appreciate you spending the time with us today. It's been a pleasure to learn about the Safe ecosystem as well as the differences in account abstraction. I want to close the loop on the 3074 conversation and the 4337 conversation because we brought up earlier how these paths may diverge. I'm curious, do you see these paths diverging over time, or do these paths ultimately converge to smart accounts and native account abstraction?
Ultimately, I believe that they converge again. It's actually the diverging is more the short-term effect, right? And the challenge for me is that the short-term effect is what happens now. And this is where it's where there's a challenge and where we will see impact, which might slow down certain processes and will change certain dynamics. But ultimately, I believe that both ways go through native account abstraction if we continue on these paths, if we don't stop halfway through. the thing is that both paths, no matter which one you take, if you take 3074 and then go for 003 and continue on further, or if you take 4337 with EIP-3560 and so on, they are hard ways. It's by no means easy. This is really where there's a lot of hurdles, a lot of things that we don't know yet. And this will require some endurance that we go through there. And this is what we need to do. This is what we need to commit to, that we continue walking and that we don't stop halfway through. And then we have this incomplete account abstraction, because this is where then if we stick with ERC-4337, how it is right now, then this will not have a long-term effect. This doesn't work on mainnet. It's no secret. It's just too gas expensive, too much gas overhead to work on mainnet really properly. And it's not meant to be. If you talk to Yoav, he will tell you, and like when we talk together, we all agree it's a stepping stone to proper native account abstraction. But this means we have to go the way. And this requires manpower, and this requires also that we push together and not try to be all over the place. But yeah, we all have the same goal, right? Like we want to go towards native account abstraction, and both ways will lead there ultimately.
Awesome. Yeah, I tend to agree. I think ultimately we're stronger together, and it's important not to split our focus and try to take both paths in parallel. But that a lot of times that's the nature of experimentation, is that we'll kind of run both of these experiments in parallel. And the one that seems to be a little bit more promising will probably absorb a lot more of the manpower, and we'll start to see a lot more support around that. Maybe right now that's 3074. Before it was 4337, maybe it'll be 4337 again. But ultimately, both of these paths lead to native account abstraction and smart accounts.
Yes. I mean, it's also, there are always the dynamics, right? Like new stuff. It's like a new toy for a kid. It's first excitement. And then after a while, you realize, this toy it's actually not that exciting. And then after a while, you feel like, it's actually, I can do a lot of stuff with it. It's like this curve. Like Lucas found this very nice curve here. Excitement, hype, and then it goes down and then it goes up again. And 437, as you said, it had hype last year, and it got into the sobering phase right now where everybody's like, it's not really that easy? And currently 3074 has this, yes, it's hype, right? Like it's definitely hype, and we will see how it turns out. But yes, there are chances that it will also go there to the more sobering phase. That being said, right, like I have to admit, right, maybe I'm too pessimistic coming from a tech background and also being like running a business to some extent. I feel focus, as you said, is important. That being said, the Ethereum ecosystem is big, right? Like there are a lot of developers. We can do certain things in parallel. It's more this might thrive for efficiency that I would love that we all work together on the same thing. But it's not that black and white.
Yeah. Thanks, Richard, for coming on and sharing some insights. Really had some really key takeaways here, and are excited for the future of Safe. And great work so far. I don't know how you sleep at night. The entire DeFi ecosystem is literally on your and Lucas's shoulders. So we commend you for your work, sir.
Thanks. Was a pleasure. Thanks for having me.
Thanks, Richard.